Hello students, today I am starting again the first module, that is the hydrology. In the previous lecture, I gave some basic information of hydrology and its scopes, need of groundwater, etc. But today I am starting with some basic definition. So at first I have started with some terms of groundwater. So what is this? So groundwater is used to denote the water which has saturated the pores or interstices of the subsoil. The water that reaches the zone of saturation. The zone of saturation, that is the ground immediately below the water table. So the water that reaches the zone of saturation, that is known as groundwater. Now the water table. It is defined as the locus of levels to which the water rises in the observation wells in free communication with the soil voids. That means the upper part of the saturated zone is also called the water table. Next term, that is the recharge. So any addition to groundwater that replenishes any draws or causes rise in water table is known as recharge. Now the another term, that is the zone of aeration. So aeration, from the term we can get the idea that is the that related with air. So aeration is a combination of air and water. How it becomes? That is, we can say the part of the subsoil of strata above the zone of saturation. So it is one of the nearest the surface, that is the zone of aeration, where gaps between soils are filled with both air and water. Next one, that is the soil water belt. So the zone of air adjacent to the surface which is used by plants through evapotranspiration, that is known as soil water belt. Next term is capillary fringe zone. It is basically situated immediately above the water table lies the moisture zone, that is called the capillary fringe zone. So water in this zone held primarily by capillary forces. Next is the vadose zone. So the immediate zone lying between the soil water table and capillary fringe contain water held by the molecular attraction. Safe field. This is the very important term. So it can define the amount of water that can be withdrawn from an aquifer without producing adverse effect. It is defined as safe field. So water withdrawal is excess for safe field is termed as overdraft. So possible adverse effects of the overdraft through excessive pumping are lowering the water table. Pumping beyond a certain level may produce inferior quality of water. Overpumping may result in diversion of water from other resources, creating shortage elsewhere, leading disputes. Excessive pumping may cause high consumption of electricity. Next is the terms are the very well known as the porosity permeability. So porosity is a void fraction, is a measure of the void, that means the empty spaces in a material. So it is a fraction of the volume of voids over the total volume. And permeability defines the ability of a rock or soil, and it's defined as ability to transmit of a fluid. So the transmissibility is defined as the rate at which groundwater is transmitted through a unit width of an aquifer under a hydraulic gradient. The next one is the groundwater basin. So it may be defined as hydrogeological unit contain one large aquifer, several connected or interconnected related aquifer, and it implies an area containing groundwater reservoir capable of furnishing a sustainable water supply. So in the previous lecture, I told about the hydrological cycle and its processes. Now I am describing all the processes one by one. So let's revise what are the hydrological processes. So this is the process of the water where the water evaporates and it from the ocean surface, and it driven by the energy from the sun and joins the atmosphere and moving inland as clouds. So once inland, atmospheric condition act to condense and precipitated water onto the land surface, where driven by the gravitational forces, and it returns to the ocean through river and stream. So in one sentence we can say the continuous recirculating transport of water of the earth linking atmosphere, land and ocean. So the first process, that is the precipitation. So it is the atmospheric discharge of water in the form of solid, liquid from the earth's surface. So the distribution of the water on the surface and subsurface that is governed by duration and intensity of the precipitation. So forms of the precipitation that should be in the form of rain, snow, drizzle. Basically, rain is the main form of the precipitation in India. When the size of the drop is larger than 0.5 mm, it is called rainfall. Whereas snow is made up of one or more tiny ice crystals that come together to form the unique shapes of snowflake. Whereas drizzle is a light liquid precipitation consisting of liquid water drops smaller than those of rain, generally smaller than 0.5 mm in diameter and having intensity less than 1 mm per hour. So the next process, that is the interception. So when precipitation reaches the surface in the vegetated areas, a certain percentage of its retained or intercepted by vegetation, rainfall is not intercepted, that is referred as trough fall. So water that reaches the ground via the trunks and the stems of the vegetation is called stem flow. So the interception storage capacities of the vegetation is called stem flow. So the interception storage capacities of the vegetation that vary with the type and structure of the vegetation with the meteorological factors. So measurement have shown that up to light millimeters of rainfall can be intercepted by some vegetation canopies. And then the intercepted water is evaporated back into the atmosphere at rates determined by prevailing meteorological conditions and the nature of the vegetation. So in humid temperature areas, evaporation of intercepted water that can be an important component of the water balance. So forest areas have been shown to have greater interlosses than adjacent grassland areas. This is due to the greater aerodynamic roughness of the forest canopy, resulting in much more efficient of water vapor away from the surface. The next process, that is the evaporation. So it is one of the major process in the cycle. It is the transfer of water from the surface of the earth to the atmosphere. By evaporation, water in the liquid state is transferred to the gaseous or vapor state. So, this transformation occurs when some molecules in a water that have attained a sufficient kinetic energy to eject themselves from the water surface. So the main factors we can say that are affecting the evaporation are temperature, humidity, wind speed and solar radiation. So the direct measurement of the evaporation through desirable is difficult and possible only at point location. The principal source of water vapor is the oceans, but evaporation also occurs in soil, snow, ice. Evaporation from snow and ice, the direct conversion from solid to vapor is known as sublimation. So transpiration is the evaporation of water through minute pores or stomata in the leaves of plants. Now, the evapotranspiration is the sum of the evaporation and transpiration. So, evaporation is defined as the water lost to the atmosphere from the ground surface and evaporation from the capillary fringe of the groundwater table, the transpiration of the groundwater by plants whose root stops the capillary fringe of the groundwater table. And infiltration is the process by which water on the ground surface enters the soil. It is governed by two forces, gravity and capillary action. So, infiltration rate is a measure of the rate at which a particular soil is able to absorb rainfall or irrigation. So, the rate decreases as the soil becomes saturated. The overland flow is a movement of the water over by the land downslope toward a surface water body. It is very important aspect of the water cycle and it can be generated under two different physical mechanisms. The infiltration excess overland flow is formed when the rainfall intensity exceeds the soil infiltration capacity in an area. Then water accumulates on the soil and starts moving the downslope due to gravity towards the hydrographic network. The second mechanism that occurs when the soil saturation exceeds its maximum level due to the groundwater uplifting, base flow and lateral subsurface water discharges resulting in the appearance of saturation excess of overland flow. Next process, that is the runoff, that is the quantity of the water discharged in the surface streams. So that includes not only the waters that travel over the land surface and through channels to reach a stream, but also interflow the water infiltrate the soil surface and travels means of gravity toward a stream channel and eventually empties into the channel. So, runoff also includes the groundwater that is discharged into a stream flow that is composed entirely of groundwater, that is termed as base flow. So, or we can say the fair weather runoff, and it occurs where a stream channel interact the water table. Next process, that is the groundwater flow. So, that means how much flows from surface to groundwater. It typically includes evaporation or transpiration. It typically occurs in the areas where the water table is shallow. Now, I am coming the part in the global scenario in respect to our Earth. So, our Earth is called blue planet as 70% of the Earth is covered by water. So, distribution of water already told in the previous lecture. So, this scenario of the water distribution when no intervention is anticipated. Water use increasing everywhere every year. Currently, 69% of all water withdrawn for human use on an annual basis is soaked up by agricultural, including irrigation. Industry accounts for 23% and domestic use, that means the household, drinking water, sanitation purposes, that accounts for about 8%. So, these global averages vary a great deal between regions. From 23% of water use for industrial purposes, in which high-income countries have used only 59% of the total water, whereas the low-income countries used 8% of the total water. With the decrease in the resource and increasing trends of water demand by various user sectors, like sharing concept is coming up and is becoming complicated too. So conflicts related to the water users are increasing everywhere by social, ecological, economical values. Per capita availability of water in 1950 is reduced to 60% in developed countries and 30% in developing countries in 2000, and that will reduce to 57 to 58% in developed countries and 23 to 24% in developing countries in 2025 year, like 2025. So in India, now I am coming the India scenario. So in India, it is estimated the sectoral water requirements are 85%, 7%, 5%, 3% for agriculture, domestic, industry and energy purposes. So the geographic area of India is about 3.9 million hectares, like the 2.45% arts landmass, and population is 1.324 billion in 2016, which is 60% in the world. So also in the distribution pattern, due to the geographical variation that are difficult to both by space and time. So in India, out of total rainfall in an area of 3290 lakh hectare, a rainfall of 4000 billion cubic meters annually occurs. Out of the total, 41% is lost in evaporation, 40% is lost in runoff, 10% is retained in soil moisture and 9% is seen for recharging groundwater. So out of the 40% stream flow water, 8% is used for irrigation, 2% for domestic use, 4% for industry and 12% for electric generation. To manage this unevenness, the interbasin transfers of water emerged as important strategy. The Indian program of river linking and transfer huge volume of water from one basin to other basin also in progress. So water conservation implies improving the availability of water through the augmentation by means of storage of water in surface reservoir, tanks, soils and groundwater zone. The shortage of the water in the country is slowly affecting the lives of the people as well as the environmental around them. As a result, the excessive extraction of groundwater to meet agricultural, industrial and domestic demands, drinking water is not available during the critical summer months in many parts of the country. About 10% of the rural and urban population doesn't have access to regular safe drinking water, and many more threatened. So contaminants, namely fluoride, arsenic, selenium, that pose a very serious health hazard in the country. Ingress of seawater into coastal aquifer as a result of over extraction of groundwater has made water supplies more saline, unsuitable for drinking and irrigation purposes. So pollution of ground and surface water from agrochemicals and from industry that possesses a major environmental health hazard with potentially significant cost to the century. So that's all for today. Thank you.